tutorial, we're going to look at scientific notation. Now, scientific notation is kind of a shorthand way to write very big and very small numbers. And in this class, we'll be using a lot of those. And it just keeps you from having to write so many zeros. It makes numbers a little bit less unwieldy. Let's take an example here. Let's think of a really small number. We'll start with a really small one. Let's say that we're going to have 0.00, come here, pen, 0.00000098, and then 2. Now, nobody wants to put all that into a calculator. Nobody wants to write all those zeros over and over and over again. So here's where scientific notation comes into play. And it has to do with multiplying and dividing numbers by powers of 10. So in this particular example, we have a decimal point at the far left here because it is a number that is much less than 1. And so we're going to begin writing our number in scientific notation by beginning to write the first number that is non-zero from that decimal point. So that number in this case is going to be 9. Then I'm going to put a decimal point behind that 9 and continue with all other digits behind that decimal point. This indicates the level of precision of this number, okay? So now I've got 9.82, but that isn't really what the number is. What it is it's 9.82 times some power of 10 that's going to give me exactly the number that you see here. Now we're going to count decimal places. 1, 2, 3, 4, 5, 6, 7 decimal places is what I had to move that decimal over in order to get my 9.82. So that is -7 is our exponent. Okay, so if I take 9.82 times 10 to the -7, I'm going to get this number that we began with right here. So this is that same number written in scientific notation. Let's look at a much larger number. Let's look at something like 72 million. Oh, maybe I'll even make it bigger than that. Again, I do not want to write all of these numbers, okay? There is an understood decimal point at the end of all of these large whole numbers. Okay, so that's important that you understand that. Now, we begin the same way we did with the very small number. Write the first digit, put a decimal point behind it, and follow that with all the digits that are non-zeros. And then I'm going to stop. Okay, times. Now what power of 10 can I multiply this number by in order to get the same number that we started with? Well, let's see. This time I'm going to look at where my understood decimal place is, and I'm going to count the number of places that I need to move it. So here's 1, 2, 3, 4, 5, 6, 7. It's hard to do with a digital pen. 8, 9, 10, 11, 12, 13. Did I get it right? 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Times 10 to the 13th power, because this is a number much larger than 1. And that's how you do scientific notation. That's it. Let's try one more. Let's do one of each and let you see it again. Let's start with one that's a small number. Sometimes you'll see a 0 in front of the decimal. It just makes it easier to read. We'll do this. And this here. This pen is not wanting to write today. Come here, you. All right, there we go. How do we start? Think about it. What do we do first? That's right. Write the first non-zero digit that you see, that's a 1. Put a decimal behind it, and follow that with all the rest of the digits in the number, including the 0 there. Then we're going to multiply that times what power of 10? Okay, so take a look here. How many decimal places do we have to go in order to get that 1.3? So it'd be 1, 2, 3, 4 places. And so we write -4. That means divide by 10 to the 4th. Okay, and so there's our number in scientific notation, 1.30 times 10 to the -4th. Let's try a large number, 7, 3, 4, let's see, 5, 0, 0, 0, 0, 0, 0. All right, let's see what we got here. Making up numbers as I go along. 7,345,000,000. All right, let's see how we would write that. What do we start with? Well, we start with that first number, put a decimal, and then every number until we get to the string of zeros. Times 10, and what exponent are we going to use here? What power of 10? Well, remember we've got an understood 0 back here. Okay, and how many places are we going to move? We got 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. And that's it. Scientific notation. Now you practice a few with the practice problems.